Hello guys, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Channapur. Dear students, in the previous class we discussed about what is thermal science and what are the branches of thermal science. Okay, what is difference between the heat transfer and thermodynamics? We have discussed in detail with the examples, and also we discussed what is temperature and how to measure the temperature and what are the units for temperature. Okay, we have discussed. And also we discussed about what is heat energy, okay, what is the unit for heat energy, okay, how the heat is going to transfer and what is the sign convention for heat energy. In detail we have discussed by taking some live examples, dear students. Let's come, we'll move towards next topic. That is our first chapter in heat transfer, that is introductory concepts and definition of heat transfer. Module 1 of heat transfer, that is introductory concepts and definition of heat transfer. Dear students, what we have discussed till now, those are the basic concepts which are required for heat transfer. Now we'll move towards first chapter, that is introduction to heat transfer. That is the first module or first chapter. In that first chapter, we are going to discuss about what is heat transfer. Dear students, while in previous class, just I given you what is heat transfer definition, right? So now onwards, we will try to understand what is heat transfer in detail. Okay. Now, so heat transfer. Dear students, what I will do here now. Here you can see what is heat energy. So now already we know what is heat or heat energy. It is nothing but what? Heat energy that can be transferred from one system to another as a result of temperature difference. That I have already explained. What is that? Heat energy is nothing but what? That energy, heat energy is represented by E. Some authors they will take Q. Okay, but I will take here heat energy is represented as a E. Okay, due to change in temperature, what will happen now? A kind of energy is going to transfer from high temperature region to low temperature region. That energy I will call it as a heat energy, dear students. Now, okay, that is nothing but what? Heat energy. Next one, what is heat transfer? Now, heat transfer, that is nothing but it is a branch of science that deals with the determination of the rate of thermal or heat energy transfer is called as heat transfer. So I repeat, what is heat transfer? It is a branch of science that deals with the determination of rate of thermal or heat energy. That is nothing but heat transfer. How it is, dear students, you can see here now. You are telling, right? Yes, there is a hot coffee cup is there on the table. That the temperature of that coffee is 70 degrees Celsius. The ambient or surrounding temperature is 20 degrees Celsius. Then you are telling that energy is transferring from hot coffee to surrounding. That energy is represented as a E. But this is what heat energy is getting transferred from high to low temperature region. That's fine. But how much amount of heat energy is getting transferred? That is nothing but heat transfer. Heat transfer, what it is going to do here now? It is going to heat transfer. I will call it as a HT. Heat transfer is a branch of science that deals with the determination of how much amount of heat energy is transferred for unit time. That is nothing but heat transfer. What is heat transfer? Heat transfer is a branch of science that is going to determine the amount of heat transfer. I will mark here just a minute. Amount of heat energy transfer for unit time. That is nothing but what? Heat transfer. Then that heat transfer or rate of heat energy or rate of thermal energy is represented by notation Q, where Q is nothing but what? Heat transfer. What is heat transfer? Rate of heat energy or thermal energy transfer for unit time. That is known to be heat transfer, dear students. Now, so with the help of temperature, we can see here now temperature high and low, we can determine at what direction that heat is getting transferred. That also we can determine, because we know already naturally heat is going to transfer from high temperature region to low temperature region. Hence what I can say, by seeing these two temperature, I can say that heat is flowing from hot coffee to the surrounding. Hence the direction of heat flow is from hot coffee to the surrounding. So if you call it as a system, then what we can say, heat is transferring from system to the surrounding. According to thermodynamics, you can give the direction for the heat energy. This is one example, live example to understand what actually heat transfer. Okay, fine. Next, dear students, to understand better, I will take a live example here now. What is that? You can see here, dear students. So what I will do, I will take a 10 hot box. 10 hot box. Here it is a 45 degrees Celsius. Assume that this point I will call it as point 1 and this side I will call it as a point 2. Okay, now this side temperature is 25 degrees Celsius. So what I want to do, I want to transfer this hot box which is having 45 degrees Celsius from this point 1 to point 2. Then what I can do, this hot box I am going to transfer. I will first one, I will take this person, that person what he will do, he will take that hot box and he will give to second person, then second person will give to third person will give to fourth person. Like that, what will happen, that hot box is going to transfer from point 1 to point 2. Then what actually happened here now, the heat energy, because when it comes to hot box, it is having a heat energy. Okay, it is having a heat energy. That heat energy is transferred from point 1 to point 2, or one body to another body we can say, or we can say one part of the system to another part of the system. Heat is transferred, energy is transferred from one point to another point due to change in temperature. That is what 25 to 45. Because of this temperature difference, a kind of energy or a form of energy is transferred from one system to another system or one body to another body. That is heat energy. Now what I will do, how much amount of heat energy is transferred? So to calculate that or to determine that, what I am going to do, I am going to put in a timer here now. So with the help of the timer or a clock, what I will do, I will measure the time to transfer heat energy. So that heat energy is represented by what? E actually. To measure how much amount of heat energy is transferred per unit time, what I will do, I will put a clock here now. So then I will measure how much amount of heat energy is transferred for unit time. That is nothing but what? Heat transfer. What I will do, dear students, the body, what they will do for unit time per second, how much amount of heat energy they are going to transfer. That is nothing but what? Heat transfer, dear students. What is heat transfer now? Heat transfer is a branch of science that deals with the amount of heat energy transfer or rate of heat energy or thermal energy transfer, that too for unit time. That is known to be what? Heat transfer. One thing. And what is the purpose of this heat transfer? Heat transfer is to determine only amount of heat transfer for unit time? No. It is used to calculate, it is used to determine the temperature distribution or to predict the distribution of temperature in a system. This is also one of the purpose of heat transfer. With the help of heat transfer, what I can do, I can determine the amount of heat transfer for unit time or rate of heat transfer from system to the surrounding, or it may be vice versa, surrounding to the system, to determine the amount of heat transfer. One thing for unit time, first purpose. Second purpose is what? To determine the temperature distribution along the system. So to do this, what I can do, I can use the heat transfer, dear students. Okay, fine. Now, so that heat transfer, dear students, as I told you, okay, this is a system, you can say, according to thermodynamics, you can define it is a system. It is a system. Now what I can do, what I can tell now, if the system temperature is 70 degrees Celsius, atmospheric temperature is 20 degrees Celsius, obviously what will happen, the heat is going to transfer from system to the surrounding. That heat or energy, we can mark it here E. So how much amount of heat energy is transferred for unit time is nothing but what? Heat transfer, dear students. Now how much amount of heat is transferred from system to the surrounding. This is one case. If surrounding temperature is 50 degrees Celsius, then system temperature is 20 degrees Celsius, then what will happen? The heat is going to transfer in reverse direction, 50 degrees Celsius to 20 degrees Celsius. That too, if you are measuring for unit time, how much amount of heat energy is transferred, that is nothing but what? Heat transfer, dear students. Okay, fine. That heat transfer notation we are giving here as a Q actually. So dear students, some authors, they will take Q as a heat energy. So here you can mark E you can take as a heat energy or you can take Q, but I will take E as a heat energy, but Q heat transfer, that we will see. So some authors they will take small q is what? Rate of heat energy, that means what? Joules per second. 1 joules per second is equal to what? 1 watt, dear students. Now what I will do, my notation, I will take E is the energy, then Q is the rate of heat transfer for unit time, that is joules or watt. This is what? Joules, energy is joules, heat transfer, that is Q, joules per second, okay, or I can write it as watt. Then I will take small q is a heat flux. Heat flux means what? Heat flux I will take it here now. Heat flux is nothing but what? Rate of heat transfer for unit area, that is watt per meter square. Some authors they will take Q double dash is heat flux, watt per meter square, and temperature some authors they will take in degree Celsius, some authors they will take it in Kelvin, but better to put the temperature in Kelvin. How to convert degree Celsius to Kelvin, that I already explained. Once again you can see here now, by adding 273 what happens, that degree Celsius is going to convert it into Kelvin, dear students. Now okay, fine. Now so what is heat transfer? We understood now. That heat, dear students, that heat we know already, that heat transfer is nothing but what? It's a branch of science that deals with the rate of thermal or heat energy getting transferred. That's fine. How that heat is going to transfer? Yes, dear students, there are 3 ways, or we can say 3 modes are there. Through that 3 modes or ways the heat is going to transfer. So one is conduction, second one radiation, third one convection, dear students. Now in 3 ways the heat is going to transfer from system to the surrounding or surrounding to the system. So what is conduction and what is radiation and what is convection, that we will see here by taking in a live example, dear students. Okay, now I will take in a system. What is heat transfer now? Heat transfer is nothing but what? Heat is going to transfer and we are going to supply certain amount of heat to the system, right? I will take system A here now. When we are going to supply heat to the system, right, then what happens? The heat is going to transfer from one part of the system to another part of the system, or one system to another system, or one system to system A to system B. If the heat is getting transferred per unit time, right, that is heat transfer. That heat transfer is going to happen in 3 ways: conduction, convection, radiation. Dear students, what is conduction? So conduction means what? I will heat the bottom of this system A, okay, then what is, it's a metal body, metal system is there. So when you are going to supply heat to the metal body, right, then what will happen? That metal body is going to absorb the heat from the heat source. Then what it will do, the atoms or molecules, what they will do, they will absorb the heat, then they are going to transfer to the heat to next set of molecules. But during that heat transfer, the molecules will be at under rest. They will not at all move. They may vibrate, but they will not at all move. If they will take heat from high temperature region, then they will pass on to the next set of molecules. But the molecules are at under rest. They will not move, but they may vibrate. And what they will do? They will help us to transfer heat from one point to another point. If the heat is getting transferred in this fashion, that type of heat transfer you can call it as a conduction heat transfer. What is conduction heat transfer, dear students? You can see here now. This is a system. The heat is going to transfer from one part of the system to the another part of the system. How? Here you can see molecules or atoms. What they will do? They will absorb. Here assume that 100 degrees Celsius, dear students. Here it is 20 degrees Celsius. Obviously we know heat is going to transfer from high to low. Then how it is going to transfer in a solid body? In a solid body, I have taken metal body, right? So the atoms, what they will do? They will absorb the heat from the hot source. Then what they will do? They will pass on heat to the next molecule or atom. But these atoms, all atoms, they are at under rest. Little bit they may vibrate, but they will not alter their position. What they will do? They will take heat. They will little bit, they will vibrate. They will pass on heat to the next molecules, next molecules. Over a period of time, what happens? The heat is going to transfer from this end to this end. If the heat is getting transferred in that fashion, that heat transfer can call as a conduction heat transfer. That conduction heat transfer, amount of heat transfer can be calculated with the help of an equation. That equation is Fourier's law of equation. What is that equation, dear students? You can see here now. Q is equal to minus K into dt by dx. Okay, in detail, again in conduction part, I am going to discuss what is these all terms. Okay, fine. This is how the heat is getting transferred. Because of molecules at under rest, the heat is getting transferred from one part to another part. That is known to be conduction heat transfer, that can be calculated with the help of an equation, that is Q is equal to minus K into dt by dx. The unit is watt actually. This is first mode, conduction. Second mode, convection. What is convection, dear students? I will take a pot here now. So in the pot water I filled, then what happens now? I will supply heat at the bottom. Then the water molecules which are at the bottom, right? What they will do? They will go and interact with the surface of the pot, okay, metal surface of the pot. Then what will happens? That's already gets heated, right? Then what will happens? The molecules will absorb the heat. Then they will absorb the heat from the bottom surface of the plate. Then what will happen? The density of the molecules become less. Because of that less density, what will happen? The water molecules, what they will do? They will try to move in upward direction. Because of this upward movement, then what will happen? That molecules, high temperature molecule you can say, or less density molecules, what it will do? It will come up and it will be going to interact with some other molecules of the water which are having low temperature. Then what happens? When the hot molecule is going to interact with the cold molecules, then what happens? The heat is going to transfer from high temperature molecule to cold temperature molecule because of molecular motion. If the heat is getting transferred from in this fashion, that means what? Convection is nothing but, that is we can call this convection heat transfer. Convection heat transfer is nothing but what? In which heat is going to transfer from one part of the system to the another part of the system due to molecular motion. That type of heat transfer we are going to call it as a convection heat transfer. Then that convection heat transfer can be calculated with the help of an equation, that is Q is equal to HA into delta T, and this equation is given by a well-known scientist, that is Newton. That law we are going to call it as a Newton's law of cooling. This is how convection heat transfer. Then radiation heat transfer. Dear students, radiation heat transfer is a mode of heat transfer in which the heat transfer is going to take place from one point to another point, but there is no any media at all, but that heat is going to transfer in the form of electromagnetic wave. That type of heat transfer we are going to call it as a radiation heat transfer, dear students. Okay, so that radiation heat transfer can be calculated with the help of an equation, that is Q is equal to sigma into epsilon A T to the power of 4. The unit for heat transfer is watt actually. Okay, so this is the modes of heat transfer, but again in detail I am going to discuss what is conduction, convection and radiation in upcoming chapter. Okay, so now dear students, to better understand we can take a live examples. When we are cooking in your home, right, the steam is coming out. Okay, so we are putting one spoon into that metal spoon into the pot, right? Sometimes what happens, you are going to feel heat actually. That means what? Heat is transferred from this point to this point in that metal steel spoon. That means what? Heat is transferring from this point to this point. In metal, that is something about what? Conduction we can say, because in metal the molecules are at under rest. They are going to transfer heat from one point to another point. While transferring that, they may vibrate, but they will not alter their position. That is conduction. Then steam, when the steam is going to enter into the air, right, then that steam is hot steam. That hot steam molecules, they are going to interact with the air. Over a period of time, that air may become also high temperature molecules. Hence heat is going to transfer from steam to air, where both steam and air molecules are under motion. If the heat transfer takes place due to molecular motion, is what? Convection heat transfer. That's only you can see here, dear students, now. Or else here, right, hot air is coming here now. That hot air will come, the hot air molecules, they are going to interact with the fire, then they will become hot molecules, then they are going to move upward. Then that hot molecules, they are going to interact with the cold molecule of air. Hence the heat is going to transfer from hot molecules to cold molecules. That is nothing but what? Convection heat transfer. If there is no any media, but heat is going to transfer from this point to this point, you can say, in the form of electromagnetic wave. That type of heat transfer we are going to call it as a radiation heat transfer. What is radiation heat transfer, dear students? There is no media at all. The heat is going to transfer from one point to another point in the form of electromagnetic wave, that is radiation. Then conduction is nothing but what? Conduction is a mode of heat transfer in which heat is going to transfer from one point to another point. Because of molecules, but that molecules are at under rest. They may vibrate, but they will not alter their position. If the heat is takes place in that fashion, that we are going to call it as a conduction. Whereas convection means what? The molecules, they will absorb the heat and they will move somewhere else. Then they are going to transfer heat to cold molecules. Due to molecular motion, heat is going to transfer from one point to another point. That type of heat transfer we are going to call it as a convection heat transfer. For that, you can take one live example in your home itself, dear students. Okay, so fine. Then what are the importance of heat transfer? Then heat transfer is restricted only in mechanical engineering? No, it have n number of applications, or it is having heat transfer applications are wide in different domains or fields. What are those? That you can see here, dear students. Heat transfer play a very important role in mechanical engineering. Why it's required? To design efficient machinery and system, we require heat transfer. Similarly, in chemical engineering, yes, to optimize the chemical process and reactions, we require heat transfer. In aerospace engineering, managing thermal conditions in aircraft and spacecraft, heat transfer is very important. In physics also, studying the fundamental principle of energy transfer, heat transfer play a very important role. Like that, it plays a very important role in material science. For analyzing the thermal properties of the materials, heat transfer plays a very important role, dear students. In biology also, yes, heat transfer plays a very important role in biology to understand the thermal regulation in living organisms, because heat wherever you can take in biology, right, in our body itself. Okay, because of metabolism, what will happen now? We are going to generate some amount of heat. If heat is transferring from our body to the surrounding, that means what? Our body is also one of the application of heat transfer. If I want to know the living organisms in my body with temperature or with heat energy, then heat transfer play a very important role. Like that, dear students, we can see n number of application of heat transfer. Yes, heat transfer is one of the best subject and application subject you need to understand thoroughly. So we have n number of applications. Some are listed here. What are those? You can see here now. Vehicles, yes, is an application of heat transfer. Power generation system, you can take heat transfer application. IC engines, steam turbine, gas turbines, air conditioning system, refrigeration, jet propulsion, compressor, water heater, computers. You can take any these applications. There is a application of heat. If I want to design this kind of engineering application of heat transfer play a very important role. Okay, fine. Now, what is the scope of heat transfer? Yes, dear students, if you want to design and develop the steam power plant, heat transfer concepts or fundamentals play a very important role. Then, if you want to design separation and liquefaction plant, yes, heat transfer is required. If you want to design refrigeration system, yes, heat transfer play a very important role. Like that, air conditioning and heating system you can take, internal combustion engines you can take, chemical power plants you can take, turbines you can take, compressors you can take. If you want to design these all things, heat transfer play a very important role, dear students. The fundamentals of heat transfer we need to apply while designing such kind of engineering applications. Okay, there are some more applications of heat transfer. To understand better, I have taken some live examples. You can take, dear students, human body. Human body, as I told, it is around 37 degrees Celsius, right? The ambient temperature, I will take it here, 27 degrees Celsius, normal. Okay, then what happens? The heat is going to transfer from human body to the surrounding. That heat is going to transfer, one in conduction, another form is convection, other mode is radiation. So heat is our human body itself. Heat has to transfer from our body to the surrounding. That is transferring in three ways: conduction, convection, radiation. So conduction generally it will be around 3%, convection is around 27%, and radiation will be around 40%, dear students. If there is no any heat transfer in our body, then what happens now? We can't live. Now our body become dead state. Dead state means what? The system, there is no any interaction between system to the surrounding. That is dead state. Yes. If I want to live, if I want to perform very well, if I want to work properly, excess heat from my body has to transfer to the surrounding. One application, you can take human body. Second, hot copy, as I told dear students, right? Heat is going to transfer from hot copy to the surrounding, right? That is nothing but that is going to transfer. That heat transfer is represented Q. That is going to transfer in three ways: conduction, convection and radiation. Hot coffee is also an example for heat transfer. Then you can take a human lung. That means what? You are going to take cold air, right? That is around 27 degrees Celsius. Then what will happen? You will inhale it. While exhaling, then what will happen? The temperature of the air becomes 35 degrees Celsius. That means what? Heat is going to transfer to the surrounding while exhaling air. That means it becomes 35 degrees Celsius. That means heat is going to transfer from your body to the surrounding in convection way, because molecules, air molecules, they are moving. Then they are going to transfer heat to the surrounding. That is known to be convection heat transfer. Hence, inhaling and exhaling is nothing but what? Or you can take a lungs is an application of heat transfer. Like that, you can take IC engine. And one more interesting thing, dear students, is that most of animals come into this world with built-in insulation, but human beings come with a delicate skin. Yes, we are having delicate skin, but you can take any kind of animals or birds. They are having an insulated skin. Insulated skin means what? The insulation means what? Sometimes what happens, dear students, you can take a winter season. That bird has to retain its heat, because if it is 15 degrees Celsius outside, if it is going to live comfortably at 25 degrees Celsius, then what it has to do? It has to retain, or it has to prevent the heat transfer from its body to the surrounding. Then what happens? The skin is act as an insulating material. That insulating material is nothing but what? It's a material which is going to prevent the transfer of heat from system to the surrounding or surrounding to the system. Hence, again, if I want to know the living organisms in the bird or animals, heat transfer play a very important role, dear students. Like that, you can take, if you want to design any kind of home applications which are related to heat, again, the fundamentals of heat transfer play a very important role. That cooker may be electrical, cooker may be gas cooker, or whatever it may be. These all are designed based upon the fundamentals of heat transfer. Dear students, you can take it here now. When man is running, right, then heat is going to transfer from body to the surrounding in the form of evaporation. If it is in the form of evaporation, means what? Heat is getting transferred from body to the surrounding in the form of what? Convection mode. In the form of convection, heat is going to transfer. Evaporation. Some amount of heat is going to transfer to the earth also. That is what? Conduction. Some amount of heat is going to transfer without any media, but that is going to transfer in the form of electromagnetic wave. That is nothing but what? Radiation. Hence, human body is also one of the best example for application of heat transfer. Like that, you can take a solar water heater, radiator you can take, okay, then a resistance heater you can take, human body I already told, oil engine you can take, okay, you can take cooker, either gas cooker or electric cooker. These all are application of what? Heat transfer, dear students. Okay, so very specifically you can take, when hot egg is placed on the table, right? So if I want to cool this, what I have to do? I need to transfer heat from hot egg to the surrounding. Here what happens? The cold air will come and they are going to interact with the hot egg. They will absorb the heat and they will come up. When they are coming up, right, they will become warm air. Because of this movement of molecules, the heat is transferred from this point to this point. That is nothing but what? Convection heat transfer. Hence, hot egg, cooling of one hot egg is nothing but what? It's an application of heat transfer. Like that, you can take, dear students. Now, here if it is a 15 degrees Celsius, if here it is a 30 degrees Celsius, heat has to move from high temperature region to low temperature. Over a period of time, soda will become cold. This is an application of what? Heat transfer. If you want to design cold soda bottle or something else, you require heat transfer. Like that, fire burning. So fire burning or fire camp, you can see. Again, the heat is going to transfer from this point to this point. If there is no any media, if heat is transferring from this point to this point, is nothing but what? Radiation heat transfer. Like that, you can take n number of application, dear students. Then solar, you can take a solar systems, okay, or solar energy. Heat is going to transfer from sun to the earth. There is no media at all, but it is transferring in the form of electromagnetic wave. That is radiation heat transfer. Hence, what I can say now, this is nothing but, this is also an application of heat transfer. Without knowing application of heat transfer, it is very difficult for me to design any solar applications. Like that, you can take n number of applications you can get, dear students. Refrigerator, power plant you can take, automobile engines you can take, lamp burner you can take, human body you can take, lungs or biomedical applications. For cremation also, the heat transfer fundamentals play a very important, dear students. Okay, dear students, I hope you understood today's class related to heat heat transfer. If you really like my videos, please do subscribe, like and support me. Your supports helps me a lot. For more and more video, please do subscribe my channel. Thank you.